Hello, today we will learn about functions and graphs. So there are two types of variables. We have independent variables and dependent variables. Independent variables are variables that do not depend or are not changed by the change in another variable. So change on their own, kind of. And dependent variables are those variables that change because of a change in another variable. So independent variables are mostly drawn in the x-axis and dependent variables are found in the y-axis. So these are our this is our coordinate system. Here we have x and here we have y. So in the x-axis we have the independent variables and in the y-axis we have the dependent. Now let's look at some examples that will show you what I mean by this. So if we have this statement, the circumference of a circle increases as the radius increases, we see that the radius increasing is a change that happened on its own. We don't know what caused the radius to increase. However, the circumference increasing, we know is due to the change in radius. So as I mentioned in the previous slide, the independence is a change on its own, and the dependent is a change because of a change in another variable. In this statement, we have found that the circumference is our dependent because it depends on the radius, and the radius is our independent variable. And now we see that when the radius increases, the circumference increases as well. So if we were to graph this, we have x and y, and we can say that x is equal to radius and y is equal to circumference. Okay, and we know that they both increase, so we know that it's gonna go like that. However, something to keep in mind is that we don't know if it's a straight line. It could be like this, and as you might see, when x increases, so when x becomes bigger, y also becomes bigger. So we don't really know the shape, but we know that it's gonna go up and to the right. So now let's look at a graph and try to interpret what it means. So we have this graph right here. We know that the x-axis is equal to the time and the y-axis is equal to the distance from home. So let's say that we're talking about Eric. So what is Eric doing? So Eric, for some time, is going somewhere because his distance is increasing. Let's say that this is equal to maybe 17 miles and his work is 17 miles from home. So if this is the case, we see that he travels 17 times in a given time, 17 miles, in a given time. So we suppose that he's going to his work. So first, Eric goes to work. And then what happens? Well, his distance is not changing, so it stays at 17 miles for a while. So the time, let's say that this is 6 hours. So he's at work for 6 hours. So then he stays at work for 6 hours. Then what happens? Well, here it seems like he goes closer to home, but he doesn't stay there. He just keeps going somewhere else. So we can say that maybe in this V right here, either he went somewhere and just picked something up very quickly and it was closer to home than he was before, or maybe it was part of the trajectory. So here we will say that his trip was not linear. So if it was linear, either it would have always been downward, so always getting closer to home, or it would have only been upward, so always getting away from home. But since we see that sometimes he's closer, sometimes he's further away, we know that it's not going to be, the trajectory was not linear. But then he went somewhere pretty far away. Let's say this is equal to 30 miles from home. I don't know. This scale would be too bad right here, so 40 miles. So, and let's say that his mother's home is 40 miles from home. So, now we know that he went to his mother's house, and stayed there for a while. So we will say that this is 5 hours. So 4 stayed at mom's house for 5 hours. And then what happened? Well, his distance from home decreased over time. So he drove back home. Okay, very well. So now something to see here is that the place where he was depended on the time it was. So from maybe this is from 8 a.m. to 2 p.m. And so we know that if it's somewhere between those two times, he's gonna be at work. So the distance from home, where he is, depends on the time it is. So we know that time is our dependent variable and his distance from home is the time is our independent variable and his distance from home is our dependent variable.